Hello, in this section of tutorial we are going to learn how to deal with data files. So far in our program we read all necessary data that the program is going to process from keyboard, and we have written the result, the processed data, into the monitor or standard output console using the printf function. But that's not practical all the time. We may need to input data from a data file, and we may need to write back the processed data into a data file so that the result could be preserved. Because always what we do, we declare data structures like array in primary memory, and they contain the data for processing, and the program manipulates data in data structures or variables. But as soon as the program ends, all these data structures and variables are deallocated, so the data that we process are lost. So in order to preserve the data, we need to write it from our program into a data file, and we can get it back later on just by reading the data file or scanning the data file. So we need to learn the technique by which we can create a data file from within our program, and we can read data from a data file, and we can write the processed data whenever necessary into a data file. First of all, there are two types of files that we are going to deal with. One is the text file and another is the binary file. Let me just give you one example to make you understand what's the difference between a text file and a binary file. Say we have a variable x, and that is assigned with value 12. Now if I go ahead and print the content of x using the printf statement, then it's always going to be 1 to 12 in the output console. This is going to be printed. So this is human readable, this 1 to 12, and that's a text format data. What printf does, it converts the content of x from binary that's kept in the memory in the binary format into a text format that's human readable and prints it in the console. Actually, the content of x that's kept in the memory is this one. This is the binary equivalent of 12 in 32 bits. Now if our intention is to write the text format value, that is this one, into a file, then we need to create the text file. Otherwise, if we want this binary format value to be written into the file, then we need to deal with binary file. So if we need to read and write with binary format, then we need to create binary files or need to open binary files. Otherwise, if we need it in text format, then we need to create text files. In order to work with file, the first thing that we need is a file pointer. So in this program, I'm going to write some characters into a text file. So for that, the first thing we need is a file pointer. This file is a structured type, and that's declared there in the stdio.h header. It's going to hold the address of the file object corresponding to the file with which we are supposed to interact. So the next thing is that we need to open the file using the function fopen. This fopen is a library function, and in order to work, fopen requires two parameters. The first one is the name of the file, and the second one is the mode of operation. Now if fopen can open the file successfully, it returns the address of the file object created corresponding to the file that we specify as parameter. So we can assign that file pointer here in some variable so that we can use that later on in order to read or write with the file. If fopen fails, there are occasions, many occasions when fopen could fail. So if fopen fails, fopen returns null. So immediately after the call to fopen, we need to check whether it was successful in opening the file or not. So if the content of the file pointer returned by fopen is null, then obviously the file open was failed, and we can just go ahead and print a message and return from the function. So I'm returning from the function with status code as 1. That's for exit underscore failure, so that the caller environment understands that something went wrong with this program. Okay, the first parameter to the fopen function, as I said, it's the name of the file that we are interested. So if I want to open this file a.txt, I can just write it as a string. That means within double quote as first parameter. Now the fopen function is going to look up for this file a.txt within the current directory from within which this program is executed. If I want it to be looked up for in some different location, then I can just provide the absolute path. if you are working in Windows and you want this file to be there at ABC folder under C drive, then you can just write the absolute path in this way. In this case, the file a.txt is going to be looked up there under ABC folder, which is at C drive. So I'm working in Mac, so I need this file to be here. Say I want this file in my home directory, and it's user/user/shivaji is my home directory, and we have a folder there named data_file, and I want it to be created there. So this is the absolute path for the file a.txt in my system. You can go ahead and give any convenient location where you want your data file to be. Let me just go ahead and show you the folder. Here it is, data_file. That's within the home directory Shivaji. You can see that this is my home directory, and this data_file is the folder that's there in my home directory. So this is the absolute path for my file a.txt that I want it to be here in data_file folder. Now the next parameter is the mode of operation. If I want to write into the file, then and in text mode, then it's going to be W, and if I want to write in binary mode, it's going to be WB. Now if we want to open the file in writing mode and the file is not existing in the specified location, then always the file is going to be created by fopen function, if obviously the location supplied is correct one. Otherwise, if the file is existing one in the specified location, then the content of the existing file is going to be lost. That means the file is going to be created afresh by fopen function in writing mode, and the fopen returns the address of the file pointer in that case. Now if the specified location is not correct, then always fopen is going to return null. Now if we try to open the file in read mode, then the character is R. We need to pass R within double quotes as a string. So if the file is not existing one, then fopen is going to return null, because it's quite illogical to read from a file that's not existing. So if the file is existing one, then only the file is going to be opened in read mode, and the file object is going to be created, and fopen returns the file pointer in that case. Now in append mode, we need to write A, and in append binary we need to write AB. So as in case of read binary, it's going to be RB. So in append mode, if the file is not existing, then it's going to be created just like the write mode, and if the file is existing one, then the new content is going to be added from the current end of file location. That means we can add on new content with the existing content. That's not possible with the write mode. In write mode, all the existing content gets lost, but in case of append mode, we can go ahead and add up some new content with the existing content. So let me just go ahead and open the file in write mode, in text write mode. Had it been in binary, we would have written WB. So if we come here, if the control comes here, that means the file has been opened successfully. So now we can write into the file, and for that we use this function fputc. Now the function fputc is again there declared in stdio.h header. It can write a single character into the file. In this tutorial, I'm going to show you how to write a single character. In the next tutorial, I will show you how to write different formats data into the text file. So in order to write a single character into a file, we can use this fputc function. The first parameter to this is the character that we intend to write. This can be A. And the second parameter is the file pointer where this fputc is going to write. So now fputc is going to write into the file which is being pointed by this file pointer. That's actually this file that we have used while opening the file using fopen. And not only fputc writes the character into the specified file pointer location, it also forwards the file pointer to the next writable location. That means if we call the fputc again, then it's going to write the next character into the next location in the file. That means in this case, two characters are going to be written, first A, and in the next location it's B. Now at the end, we need to close the file in order to write all the things correctly into the file. Call this function fclose, that's going to close the dynamic file object, and it's going to flush the content into the file. So it's always required so that the file could be saved properly. And at the end I'm just printing a message to make sure that all happened correctly. Now I'm going ahead and running this program, and you can see that I'm just running this program by opening this data file folder to you. You can see the data file folder on the left hand side, and I'm running this here. Here you can see that a.txt file has been created immediately when I executed this program, and the content of this data file is going to be AB, obviously in lowercase. You can see that. Okay, now I'm going ahead and writing a for loop that's going to write from A to Z. So let me just declare a variable ch, and I'm writing the for loop. Here we start from, say I'm writing from capital A, and I need to write up to capital Z, and each time I'm increasing the character by 1. So in this case the fputc is going to write this variable ch that contains the character, and this one is not required. Okay, now you can understand this for loop. This is quite straightforward, that we are starting from capital A and we are going up to capital Z, and each time the character is incremented to the next one, and using this fputc, each time we are writing the character into the file pointer here. That file pointer is actually pointing to this file. Okay, so on execution of this program, it's going to write capital A to capital Z into this file. Remember that this file is containing small a, small b, and so that's going to be overwritten because we have used W here, so existing content are going to be lost. So here we go. I'm just opening the file once more. So here it is, from capital A to capital Z. It's not small ab there. Now had you opened the file in append mode, then obviously the contents are going to be added with the existing one. Let me show you that as well. So I'm opening the file in append mode. I'm changing it from small a to small z. So earlier it was capital A to capital Z, that's already written into the file. So now with that content, the small a to small z is going to be added. Let me execute and show you the result. So it's success, and I'm opening the file once more. You can see that this small a to small z has been added with the existing content, that's this one. Thank you.